So we have seen prochlorperazine, trifluoperazine, and other structures. Okay, and also saw the synthesis of promazine and hydrochloride. Then chlorpromazine structures, trifluopromazine, and we have compared three structures. Then let us proceed forward with the remaining structures. So the next structure is thiothixine. So thiothixine comes under thioxanthines, right? Thioxanthines is the next category, second category. In that, we have thiothixine. Thiothixine. So, what is the difference here? In phenothiazines, we have sulfur and nitrogen as heteroatoms. Here, the nitrogen is missing, and we have carbon in the place. So, if you observe, nitrogen is replaced with carbon in phenothiazine. Okay, and here in the second position, you have SO2 and CH3 and CH3, and the side chain is CH, CH2, CH2, and CH3 and CH3. So thioxanthines having the structure in which the three fused rings having only sulfur as the heteroatom. So remember this one and compare phenothiazines with that of thioxanthines so that you can easily correlate. Okay. So thiothixine will have difference at this position, and you have double bond here. Okay, to the side chain, and one moment. Here nitrogen instead of having two methyl groups attached to it, you have piperazine ring. Piperazine ring. Okay, to this piperazine ring, we have CH. Sorry. So this is the structure of thiothixine. Okay. So earlier side chain is that of chlorprothixine. Okay. I was just confused. So I am just modifying and giving you clarity. So the side chain includes piperazine ring. So let us compare the structure of chlorprothixine here itself. Okay. Chlorprothixine. This also belongs to thioxanthine. So here the nitrogen is also replaced here with the carbon. Okay, here instead of sulfur dioxide side chain, you have chlorine atom at second position. Fine. And the side chain again is an alkenyl. Alkenyl chain, double bond CH, CH2, CH2, N, CH3, and CH3. So if you compare the structures of chlorprotixin and thiothixin, remember that in the side chain you have sulfur dioxide for thiothixin and you have chlorine instead in the chlorprotix. Fine. As well as in side chain you have piperazine ring in thiothixin while you have anion dimethyl group. Anion dimethyl amino group. So this is the comparison between thiothixin and chlorprotixin. Fine. Next we see dibenzoxazepines. The third category, dibenzoxazepines. So what example we have? Only one example, that is loxapine. So if you observe the structure, dibenzoxazepine. So we saw the structure of diazepine. Diazepine was having two nitrogens and it is a seven-membered ring, right? So let us see how oxazepine looks. Okay, so benzodiazepines, we have benzene fused. Here also benzene is fused to a seven-membered ring having oxygen and nitrogen as heteroatoms, and, and it is a seven-membered ring having double bond here. Here you have a chlorine attached. Okay, it also can be written like this. If you want to compare it with that of diazepine ring, benzodiazepine, I'm writing the structure here. So this is a mirror image. Okay, so this is how we have written benzodiazepines. Okay, and we have written this as a mirror image. Okay, so this forms the main thing, benzodiazepines, to compare with benzodiazepines. So this is how dibenz oxazepines. So here we have dibenz. So two benzene rings fused with the oxazepine ring. So the middle one is the oxazepine, oxygen, ox. Aza comes for nitrogen, and it is a seven-membered oxazepine. So let us see the attachment. Okay, the substituent present at this position. That is a piperazine ring with a methyl substituent here. You can remember either of the structures. And this is the salt of succinate. So how succinate looks? CH2, CH2, CO, OH, CO, OH. So this is the loxapine succinate. Okay, this is a dibenzoxazepine derivative. And the next category we have is dibenzodiazepine. Dibenzodiazepine. 7-membered rings. We are coming across 7. Okay, the example we have clozapine. Okay, so diazepine, you know. Okay, so benzodiazepines, if you fuse one more benzene ring on the other side is the dibenzodiazepine. So the whole structure looks similar to that of loxapine, but the difference is that only you have the dibenzodiazepine ring instead of dibenzoxazepine ring. That means instead of oxygen, you will have nitrogen. I'll draw the ring. NH N. Okay. Full bond here. So dibenzodiazepine. And you have piperazine side chain, piperazine, the side chain, and you have CH3 here. So you can relate. Here you have a chlorine substituent. If you observe, the difference is that only nitrogen instead of oxygen in loxapine is the difference between loxapine and clozapine. Okay, this is the differentiation between dibenzoxazepine and diazepine. Both are 7-membered rings having two benzene rings fused on either side. Okay, dibenzoxazepines will have oxygen as second heteroatom. In dibenzodiazepine, you have two nitrogens as hetero. Okay, otherwise the structure of loxapine as well as clozapine are similar. The only difference is with their heteroatom composition. Okay, this is how we should remember the structure. The next category is fluorobutyrophenols. That is fifth category, right? Fluorobutyrophenols. What are the two examples? Haloperidol and droperidol. Haloperidol and droperidol. These are the two examples under fluorobutyrophenols. So let us see the structure. So taking haloperidol first. Halo indicates halogen. So the name of this one. So what halogen is present in haloperidol? We have fluorine. Fluorine attached here, para position. C double bond O, CH2, CH2, and CH2. And you have a piperidine ring. Okay, to the piperidine ring, you have OH and a phenyl chloride ring. So a piperidine with alcohol, piperidiol. So remember halo, the fluorine is the halogen present in haloperidol. Okay, and you have pyridinol as the main first instance memorable portions in haloperidol. Then you have to remember the linkage. What is it? How many carbons? One, two, three, four. Four carbons gives you the prefix but. Okay, butylate. Okay, carbonyl group. So this is a fluorine. This is butyl group. Okay, and phenyl group here. And in name haloperidol, pyridinol is present. Okay, and you have to remember this phenyl chloride substituent into the pyridine. Okay, piperidine. So this is the structure of haloperidol. Let us see the structure of droperidol. I'll draw droperidol beneath the structure of haloperidol. Same here, fluorine and the link is same CH2, 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 and you have pyridine, piperidine. Okay, here it is a double bond, and further it is extended to include this one. So what is the structure fused here? Imidazole or pyrazole. So it is a imidazole. So this is the comparison between haloperidol and droperidol fused with the phenyl ring as an extension to the piperidine ring. So this is the comparison between droperidol and haloperidol. Okay. So this is all about fluorobutyrophenols. The next category is benzoisoxazole. The category is sixth one, right? benzoisoxazole. The example for benzoisoxazole is risperidone. So observe the structure of risperidone. So what is this moiety? Tetrahydropyridine is fused with piperidine, and you have a carbonyl group and a methyl substitute. So this is one part, and it is connected to other heterocyclic ring through ethylene bridge, and the other side you have tetrahydropyridine again. Okay, here comes isoxazole fused to it. Nitrogen, oxygen, one moment. Nitrogen here, oxygen here. This is a five-membered ring. Okay, we have a double bond here, and it is further fused with a phenyl group that is having a fluorine. So this is the structure of risperidone. You have to remember. So where is the benz isoxazole? This is the benzene fused with isoxazole. So this is benz isoxazole. So the benz isoxazole is linked to the piperidine. Okay, this moiety is connected to piperidino, piperidino, pyrimidine, right? Piperidino derivative. Okay, fine. So this is benz isoxazoles. Moving to the next category, that is beta aminoketones and benzamides. We remained with the two structures. Seventh category, that is beta aminoketones. The example is molindone. Okay, molindon hydrochloride. So the structure of molindon hydrochloride. Looks like this. So this is the structure of molindon, and this is a salt of HCl. So what do you observe? Okay, this is a pyrrole moiety. Okay, and this is a cyclohexane fused with it. You have methyl group and group as substituent on pyrrole moiety. It is linked with the methyl group. Okay, fine. And this is ox and aza. Two heteroatoms and six oxygen. Okay, oxygen and tetrahydrooxygen because there are no double bonds. So this makes the structure of molindone. There is the beta keto and amino. So this is amino, okay, and this is ketone, okay, and if you observe, this is first carbon alpha to the amino. This is beta. To this beta carbon, you have a sorry. To this third carbon, you have ketone. So if you observe here, this is amine. This is alpha carbon. This is beta carbon. To this beta carbon, you have oxygen. Ketone. So as the beta ketone, it was categorized under beta amino ketones. And the last structure is benzamides sulfide. Benzamides. The structure example is sulfide. So observe this structure. This phenyl group is central atom. You have sulfur dioxide. Here it is. NH, CH2, and a five-membered ring to which you have ethyl group. Okay, this is the structure of sulfuride. How come it is a benzamide? This is benzene, right? This is amide. Benz, amide, and you have to remember the further extensions. Okay, tetrahydropyrrole with a methyl ethyl. Ethyl substitution, methoxy group here, sulfonyl sulfonylamine. Okay, sulfur dioxide extended with amino group. So this makes the structure sulfuride. remember sulfur, okay, and P for tetrahydropyrrole, and Ide for remaining structure. So with this, we have completed the chemistry of antipsychotics.